Okay, good morning. Alright. Okay, so we are going to go through this video for the Redox assignment. So this is your worksheet 13. You can update it inside your content page. Okay, worksheet 13. Okay, Redox assignment. Alright, for the date you can write as 11 April 23. Worksheet Right. So, what we have here is for question 11, I'm going to start with the structured question. Okay, we are going to look at how to calculate the oxidation states first. Okay, so let's take a look at this one. Okay, so these two cases, oxidation state is 0 because they are element. Okay, so when it's element is actually the easiest. The oxidation state is actually 0. Sorry. Okay, when it's element, it's actually the easiest. Yeah, it's 0. Okay, that is pretty simple. Okay, let's look at the next one. Okay, so at the top, okay, I have a list of oxidation state whereby you can fix one. Okay, wait. Okay, so for example, like fluorine is -1, hydrogen is always +1, and then -1 is with a metal. Oxygen most of the time is -2. Okay, so in this case, okay, I will like oxidation state of N be X, then oxygen is -2, so X equals to +2. Okay, so this case is still quite straightforward. Okay, let's look at the next one. Okay, for sodium is group 1, so it's +1. Bromine, what I want to find, so it will be +X, and then I get 3 oxygen, each one is -2, and then overall equals to 0. So X minus 5 equals to 0, X equals to +5. Okay, in this case. Alright, let's take a look at the next one. Okay, I would like oxidation state of N be X, and then I have 2 oxygen, so each oxygen is -2. So it's this way, so +4. Okay, so the next one is oxidation state is X. Okay, I have 2 chlorine. Okay, so chlorine in this case I'll assign it as -1 because it's from group 7. So X equals to +2 in this case. Alright. Okay, then let's look at the nitric acid case. Okay, HNO3. So your hydrogen is +1. Okay, let's follow here. Okay, then I have nitrogen, I'll let it be X. Then I got 3 oxygen, each oxygen is -2. In this case, the normal oxygen. Okay, so X, if you work it out, is this way. Right, okay. Then, okay, the next one, same thing. I got 3 hydrogen, each one +1. Then plus X for phosphorus, and then I got 4 oxygen, each one is -2. Okay, so +3 plus X minus 8 equals to 0, so X minus 5 equals to 0. X equals to +5 in this case. Right. Okay, so moving on. Okay, so next one. Okay, the equation will be slightly different. Okay, in the sense that I got 2 sulfur and then 3 oxygen, so each oxygen same thing. Okay, -2. Follow this case. Okay, this particular rule. Okay, okay, this one. Right. Okay, let's take a look at this one. Okay, so this one, 3 oxygen, each one is -2. Overall is a -2 charge. Okay, so 2x minus 6 equals to -2, 2x equals to +4. So x equals to +2. Okay, then for the next one, I have x plus 4, each one is +1, overall equals to +1. Okay, so x plus 4 equals to +1, so x equals to -3, right? Okay, then we have the next two things, your potassium dichromate and potassium manganate. So these two very famous oxidizing agent. Okay, for this I have 2 potassium, 2K is potassium, each one is +1, then +2 chromium, then +7, each one is -2, overall equals to 0. So 2x minus 12 equals to 0, 2x equals to +12, x equals to +6. Okay, and then for your potassium is +1, manganate, which is what I'm finding, is x. Got 4 oxygen, each one is -2, equals to 0. Okay, so x -7 equals to 0, x equals to +7. Alright, okay, so this is question 11. Alright, okay, so my next one, okay, let's look at question 12. Okay, still on page 3. Okay, so the reaction of magnesium with dilute sulfuric acid is shown below. So in this reaction, what is the substance that is okay, so the answer to all this, okay, basically I have to find the oxidation state first. Okay, so let's go one by one. For magnesium, the oxidation state is 0 because it's actually an element, right? An element. Okay, then next thing for hydrogen is +1. Okay, I'm looking at per hydrogen. It's on the per atom basis. Then oxygen is -2. Okay, these are all the ones I can fix based on what I have here. Okay, oxygen, okay, wait, oxygen is -2. Alright, and then hydrogen is +1, right over here. Okay, so I shall do a quick calculation. So 2 plus 1 and plus x for the sulfur, 4 oxygen, each one is -2 equals to 0, so x equals to +6. Okay, so your sulfur oxidation state is +6. Okay, next thing, you have Mg. This is group 2, so it's always +2. The O is -2. The sulfur is still +6. This is element. Okay, so also 0, although it's H2. Okay, right. Okay, so it's very obvious now. Okay, who is the one that gets oxidized? Okay, and then as well as the one that gets reduced, right? Okay, so it's the H2 that gets reduced. Okay, and then the Mg that gets oxidized. Okay, so oxidizing agent means you oxidize others, reduce itself. Okay, so that will be your sulfuric acid H2SO4. Okay, reducing agent will reduce others, oxidize itself. Okay, so that's what a reducing agent will do. Okay, so you hunt for the one that oxidize itself. Okay, that means the Mg. Okay, and then the one that reduce itself one, okay, will be this one down here. Okay, itself reduce one down here. Yeah. Okay, that will be H2SO4. Okay, so next part require you to explain your answer to A part 1. Okay, why your H2SO4 is reduced, because oxidation state of H, okay, decreases. Okay, so basically if you want to add on, you can say that the H2SO4 is reduced to H2S. Oxidation state of H drops from +1 in H2SO4 to 0. Okay, so remember the template. Okay, I'll say what reactant is reduced to which product as oxidation state, or which element decreases from whatever oxidation state in whichever reactant to whichever oxidation state in whichever product. Okay, so fill up the space accordingly. Okay, the space in this template accordingly. Right? Okay. So the next part. Okay, next part. You're given sort of like a half equation. Okay, yeah, with this is the electrons. Okay, so this part is about the 6 electrons. Okay, so from this equation, how can you tell the presence of acid? Because of this H plus. Presence of H plus means there's acid. Okay, because the very definition of what's an acid is a substance, okay, that dissolves in solution to form H plus. Okay, sorry, syncing the video first. Okay, never mind. Alright, okay, let's look at 13B. So what substance is being reduced using oxidation state or electron transfer? Okay, let's have a look at the oxidation state of the chromium. Okay, or actually down here literally is the oxidation state. Okay, so very simple. This one is 2x because there's 2 chromium, 7 oxygen, each one -2, overall equals to -2. So 2x equals to +14 -2, 2x equals to +12, x equals to +6. Yeah, alright. So literally potassium dichromate 6. Alright, then over here is 3 plus. Okay, so it's clear to us this is the one that is being reduced. Okay, so you say this Cr2072- is being reduced to Cr3 plus, as this one gains your dichromic ion Cr2072- gain electrons to form Cr3 plus. Okay, or the other way you talk about in oxidation state. Okay, because oxidation state, okay, our C drops from +6 in Cr2072- to +3, okay, in Cr3 plus. Okay, and then moving on. Okay, describe how your potassium manganate can be used to test for a reducing agent. Okay, so reducing agent, you want to know whether it's a reducing agent. Okay, what you do is you can add potassium manganate inside your KMnO4. Okay, so it's to test whether this is a reducing agent. If it turns from purple to colorless, then you have a reducing agent inside this test tube. Okay, so these are some describe how acidified potassium manganate can be used to treat for a reducing agent. Alright, so you are told potassium manganate will turn from purple to colorless. Okay, let's look at question 14. Okay, this I think is a relatively short exercise. Okay, so you have two natural ores of copper. One is your cupric, one is your paramelasonite. Okay, so what is the oxidation state? Okay, this one is 2x minus 2 equals to 0, x equals to plus 1. The other one, very simple. Because oxygen is always, I can fix at minus 2. So x equals to plus 2. Okay, that should be quite straightforward. Okay, next thing. Okay, let's take a look at so your copper can be extracted from cupric, okay, by heating it, okay, with carbon. So carbon dioxide is a byproduct in this reaction. Right. Okay, so explain in terms of oxidation state. Okay, why cupric is an oxidizing agent. Oxidizing agent means it's self-reduced. Alright, so from the first part, we know that this is plus 1. Then this is 0. So this is the part it gets reduced. Okay, carbon is from 0. Over here, if you want to calculate, is this way. Okay, so this one is plus 4. So this one is oxidized. Okay. Right, okay, so why is an oxidizing agent? Okay, so what we have is that cupric is reduced to copper because oxidation state of the copper drops from plus 1 in Cu2O to 0 in Cu. Alright. Okay, so this one you have to follow the template Okay, Cu2O is reduced to Cu as reduced to Cu. Okay, already given because oxidation. Okay, can. Alright, so always remember this template which reactant is oxidized or reduced, okay, to which product as oxidation state of chemical symbol. This one you put the chemical symbol. Okay, then the other case is when it gets oxidized oxidized to carbon. Okay, so oxidized to carbon because oxidation state increases from 0 in C to plus 4 in CO2. Alright, so this one you try to use the template you shouldn't have an issue. Okay, let's look at question 15. Okay, so the tin cans, okay, used as containers, okay, for food consists of steel alloy coated with a thin layer of tin metal. So the tin used to make tin cans is extracted from the ore cassiterite by reducing it with carbon, producing molten tin and molten carbon monoxide. Okay, so using the oxidation state, explain why this is redox. So you get using oxidation state, explain why extraction of tin is a redox, or this kind of very standard questions. Alright, okay, so let's look at it. So this one is -2 oxygen, the tin should be +4. This element, so 0, element also 0, so oxygen is -2, carbon is +2. Okay, so who is the one that gets reduced, and who's the one that oxidize instead? Alright, so in this case, okay, for the reduced part, we'll say that SnO2 reduced to Sn, because oxidation state of Sn drops from +4 in SnO2 to 0. Then on the other side, okay, which is this side, this one is the oxidized part. Okay, then this is the reduced part. Okay, so right, okay, so then we go into part B. Okay, so the tin used in making tin cans can be recycled by heating the used cans, okay, with fluorine gas to produce tin 4 chloride. So the tin is then recovered by heating the tin 4 chloride strongly to decompose it. Okay, so give one reason why tin is recycled. To conserve the finite amount of metals such as tin. Then tin 4 chloride, so you can have SN4 plus Cl minus. So crisscross, you get SnCl4. Okay, and then thermal decomposition, you are told that used to be extracted. Right. Okay, so thermal decomposition is basically one thing break down into two things. Okay, so the thermal means you need to be warm up. Okay, you need to heat it up, thermal decomposition. Okay, so yeah. And then the role of the chlorine gas is to make it as an oxidizing agent. Alright, I think this is it for this part of the video. You can attempt the MCQ and then let me mark it. Yeah, thank you.